you all had wonderful weekend. Happy Monday. Let's wait for another minute. Anyone has any questions for me? No. All right. Good morning, everyone. I hope you all are doing well. So last time we were working on chapter 1.2. We finished it and we started 1.3. Let me quickly do the review for what we have done in the last class in case you missed last class. So let me quickly go over with that. I have received a couple of questions regarding the lecture notes. I will suggest you guys to take the notes while we are doing or while I'm doing the lecture. Feel free to ask questions. And chapter slides are uploaded on Canvas. If you want, feel free to print it. If you want to use those on the side, you can use those as well. And I will not be able to provide the recording for this lecture because of those FERPA policies, privacy and all. But again, after two and a half or 3 weeks, we are going to meet each other at campus. So recording at that time. So I don't want to keep you getting into that habit. And later on, if I will not be able to provide it, then again, it's going to be a problem. So let's keep it simple. Try to take your own notes when we are doing this session. And if you have any questions, let me know. For your, let's say, I made chapter 1 notes for 1.2 and 1.3, and I uploaded those handwritten notes on Canvas under the module for chapter 1. So take a look at those. And if you have any questions, let me know. But for others chapter, start taking your own notes. For chapter 6 and 7, I might provide you notes because there is a lot of information. But for the early chapters, I am providing information from my STA 108 also. So use that part also. And give me 1 second. Right. Let me know if you can see my screen. Can you guys see my screen? For chapter 1?
Yes. Yes.
Perfect. Thank you. So let me show you the notes that I uploaded. So these notes you can see, Ms. Minion already uploaded those on Canvas under your chapter 1 module. It's Stat 271, chapter 1, 1.2, and 1.3. And I found an error in one of the topics, so I will talk about it. So let me just quickly review what we did in the last class, since we have only 15 minutes window for this class. So I will take 5 minutes from there, and then I can start the new topic. So last time we talked about the distribution of the variable. Where is the, sorry. When we are talking about a single variable, how to graphically distribute that. When we are talking about a variable, what kind of variables we are working with. We work with a categorical variable or a numerical variable. If it's a categorical variable, that means number or order does not make sense. But when we talk about numerical variable, that means we are working with numbers. So that's why we also call it as quantitative variable. Qualitative variable where we work with the numbers. So order does not matter when we talk about categorical variables. We can move things around, or you can say we can move categories into different places according to our convenience. But for numerical variable, this is not the case. Here we are dealing with numbers and some kind of mathematical operations we are performing on that. So that will not work if we are moving the orders. So order matters a lot for numerical variable. How to represent? We make pie chart and bar graph. We talk about both. For pie chart, we need to make sure that all the slices or all the categories, the sum of that adds up to 100% or one whole. And while bar graph, there is not such limitation. You can represent in different categories or bars depending upon the order you want to. When we talk about numerical variable, we talk about histogram and stem plot. Histogram, again, very similar to bar graph, but we work with the range. We divide into intervals, and then we look at how many observation in each particular interval, and then we make a bar using that particular numbered on your. So you make x-axis and y-axis. So x-axis you put your intervals, and y what you are looking for, how many. So total numbers will go here. And we also talk about stem plot. When we are working with a small data set, we can use stem plot to look at the rough shape of the distribution. When we are talking about two small data set, we can compare them side by side using a stem plot, keep the stem in the middle, and then leave for one data set on this side and one data set on this side. And then you can look that the shape of the distribution, does it look similar, or this one is little different. So you can compare two side by side data set using a stem and leaf plot. But again, when you have a larger data set, work with histogram, do not work with stem plot. We can use stem plot to, or you can say that we can use stem plot when we have a very smaller data set with very few stems. And what do? We split the stem into two using the information that when we are splitting the stem. So I use this example. So use your leave 0 to 4 and 5 to 9 observation here, and same thing, 0 to 4 and 5 to 9. And then you can plot your stem and leaf plot. Again, when we are working with small data set. Time plot, again, when we work something, when we try to measure something with the time, against the time, how the things are changing with the time, what were your observation or your data in this particular year, and after 10 years, how the things are changing, is it going up, down, still the same, then we use time plot. And again, box plot, we need 5 number summary to work with the box plot. When you enter your data in any software and you look for a box plot, it provides you a box plot using your data set, as well as it also gives you outlier. And what is outlier? Outlier is something that is lying outside your overall pattern. And I think we discussed last time, let's say this is my data set. So I can see that these are kind of in the order, but this is lying something very, very far from the normal data set that you have. So this is your suspected outlier, and this will make your distribution skewed. And skewed under which direction? Where your outlier is going. So if I see 100, so if I have 2, 4, 8, 10, my 100 is somewhere over here. So if I'm making a distribution, that distribution is going in this direction. So if my outlier is here, it is making my distribution, the tail of the distribution, going more towards the right side of the distribution. So if it's going more towards the right, we call it right skewed distribution. If it's going more towards the left, then we call it left skewed distribution. So again, when we talk about the shape of the distribution is either symmetric or non-symmetric. And non-symmetric is right skewed or left skewed, depending upon which direction the tail of the distribution is going. And then again, when we make box plot, we need 5 numbers. And where are those 5 numbers coming? So we will talk about that. Stem plot, and if you look at those notes, these are the examples from your slide, and some of the examples I use very simple, like how to calculate mean, median, so that you understand the concept. So this is 1A, And I'll say, so we started working on this topic, describing distribution from a histogram on an or a stem plot. So in any graph of data, first you look for the overall pattern and for striking deviation from the pattern by the outlier, etc. So when you are looking at the graph, you are going to look for how many observations to the right, left, or what kind of data set I am working with. What is the shape of the distribution? So to look at the shape of the distribution, you plot your data set and you, or if you know what your mean is, what your median is, you can also find if you are working with a symmetric or skewed data set. So first look at the shape of the distribution. So shape is either symmetric or skewed to the right or left, depending upon which side the tail of the distribution is going. So when I was looking at these nodes, so this one, the tail of the distribution is going more towards the right side. So this is right skewed distribution. Make sure you correct it in your notes. And here it is going in this side. So this is the left skewed distribution. And symmetric, when you draw a line in the center, it is dividing into two equal halves. Left hand side is roughly the mirror image of the right hand side. Center of the distribution is either the mean or the median. And I think I mentioned, but let's talk about it again. When we say mean, why do we take mean as the center of the distribution? Or when do we take mean as the center? And when do we take median as the center? First of all, we all know what mean is or how to calculate mean. So mean is nothing, it is the arithmetic average, or we denoted with X bar, is the most commonly measure of center. You add all the observation, divide with the total, and you get the mean. So let's say this is my data set. I add all of these, 1, 2, 3, 4, 5, divide with the 5, and I get the mean of the distribution. When I'm going to find the median of the distribution, very first thing that I need to do, I need to arrange this data set in order. For the mean, you do not need to arrange. But when you are looking for the median, you need to do the order set. Once you arrange the data set from smallest to largest or largest to smallest, then you can start working to find the center or the median of that particular data set. So here, mean is the sum of all observation divided by total number of observation, and it is the balancing point of the histogram. When we talk about median, median is the positional average, and that means the centermost position in the ordered list of observation. Make sure you know or write that somewhere. Sometime, like here, the data is not given you in the ordered form. When we work with mean, we added everything, divide with the total, we got the mean. But if we are looking at the median, our first step is to arrange the data set. Once you arrange the data set, look for the center observation. And how to find that? We use n plus 1th position to find the median of that particular data set. Let's use the same data set here. So when we work with the median, we will have two cases. Either your data set is even or odd. So if you're looking for even data set, that means your observations are in the even number. Your n is even, 6, 10, 15, 20. How to find the median for that? And if your data set is odd, how to find the median for that? So there are two possible cases to consider while finding the median. Case 1, if the number of observation is odd. If you have odd number of observation, it's easy to find the median because we say that odd one out. If you have 5 observations, you know that 2 observation above, 2 below, and the third observation is my median. So you can use this formula. This will give you the position of the median, n plus 1 divided by 2. So you have 5 observations here. And when we add 1 bar and then use this formula, it will be 6 divided by 2, which is 3. And I can go to my order data set and look for the third position, that is my median. Questions? Okay, so this is case one when you have even odd number of observations. Case two, when we work with the even number of observations. When we are working with even number of observations, definitely we will not find the center position that is dividing into two equal half in your data set. So you need to find that. Let's say this is my data set. We have 1, 2, 3, 4, 5, 6. 6 observation. To find the median, you need to look for n by 2 and n plus 1 by 2. So which is your third and fourth position. And again, when you use this formula, this does not give you the median. It gives us the location or the position of the median where exactly we can find median. So we can find the median between third and fourth position. So let me go to the third and fourth position. This is my third and this is my fourth. So when I'm talking about it is in between third and fourth, that means now I am looking for the mean of these two. So I'm looking for 15 plus 20 or the center term between 15 and 20. So that will be your median, in which is 17.5. So when you are looking for the median, you have two cases. Either you have either you have even observations or odd observations. So when you have even, how to find the median. When you have odd, how to find the median. And you can see that the median is 17.5. So the only thing that you need to remember for the median, or you can say the first thing that you need to remember, if you have a data set, make sure you organize that data set. If the data set is not organized, if you look at this one, if I'm looking at the third and fourth position, this is my third and fourth. So my median will be 7.5, but actually it's 17.5. So if I'm just using this raw data set, my answer will be wrong. So third position I have 10 and fourth position I have 5. But actually when I ordered it, my third is 15 and fourth is 20. So if you are not organizing your data set, there are chances that you get the wrong answer. So it gives you the position half on the left, half of the observations below median, half of the observations above median. Now, how do we compare mean and median? When we are talking about mean and median, for roughly symmetric distribution, not same. So when about the distribution, if it's symmetric, both mean and median are same. But when the distribution is skewed, one is larger or smaller than the other. In which case, which is larger, which is smaller? So case one, data is skewed to the left. If data is skewed to the left, so that means my tail always, my mean always follows the tail of the distribution. If it's going to the left, this is my mean and this is my median. So if my mean is on the left side, that means mean is smaller than the median, then the distribution is skewed to the left. If my tail of the distribution is going to the right side, if it's going to the right side, that means my distribution, or you can say my x bar is greater than m. If my mean is greater than m, the distribution is skewed to the right. And data is symmetric, both are same. Mean is not resistant to outliers. Sorry. So you can also write what is resistant measure. Resistant measures are those measures that does not get affected by outliers. If there are outliers in your data set, it does not affect your center, then it does not affect your median, then it's a resistant measure. I think I have definition somewhere here. I'll show you. So resistant measures are those does not get affected by the outliers. If there are outliers in your data set, your mean get affected. So let's use the same example that we used last time. So we have this data set. If I am looking for the mean, my mean will be 20 divided by 5. So I added all these observations, n is 5, so I get 4. So let's say accidentally I wrote 6, but it is 60. If I take it as 60, do you think my mean still remains 4 or it will change? Anyone?
It would change.
It will change.
It will change, and it will change to a higher number because this 60 is on the higher end. It's on the right side. If this is on the left side, it will reduce. So again, if you are working with the outlier in your data set, your mean will change. Let's see what happened to the median if I'm using the same data set. What do you think my median will be here? We have 5 observations. So 5 plus 1 by 2, which is 6 by 2, 3. So I'm looking for the third observation, which is this, right? So that is my median. What happened if I have an outlier, 60? Do you think it will change my median?
No.
No, it
No.
will still stay the same because I am still looking for the third observation. So median is resistant to outliers, but mean is not. That's why we use median as the center for skewed distribution. And we use mean as the center for symmetric distribution because it gets highly affected by the outliers. And if there are outliers in your data set, the distribution is not symmetric. It will be skewed. So that one thing I want you guys to know, why do we use mean as the center or why do we use median as the center? Once you know you are using mean as the center or median as the center, the third thing that we look at the overall pattern is the spread. How far each observation is away from the center. And that is called your spread. So when you're looking for the spread, you need to find if you are working with mean as the center or median as the center. If you're working median as the center, let's say, if we are working median as the center, then our spread is quartiles. And then how to find those quartiles? So let me use this. So let's say this is my 0 to 100. So this is my 100%. If I am dividing this into half, so that means I have 50% up till here, another 50% here. So when we are talking about 50%, that means I'm talking about the center of the distribution, right? So center. So when we are talking about median as the center, so median will be here. So median is 50% on the left and 50% on the right. So half of the observation less than median, half observation greater than the median. So let's say if I'm working with only this part now from here to here. So that means if I'm looking for a median of this one, I'm dividing into another half, right? So this is my data set that I'm working from here to here. And if I'm looking for, this is my another median, right? So that means if this total is 50%, this is 25%, and this is 25%. So 25% of the observation below the median, 25% of the observation above the median. So I have not done anything. I just took the half left hand side of the median and found another median. So can I do the same thing on the right hand side? So let me divide into another half. So this much is 25% and this much is 25%, and that's my median on the right of the median. So now I'm talking about 25 plus 25 plus 25 plus 25. So altogether 100%. And that's what my range is. So I started from 0 to 100. And when I'm looking for the range is maximum observation minus minimum. So we started with maximum as 100 and minimum as 0. So my range is 100. And I divided this 100 into 4 equal 25% part. Think of that as a dollar bill. I divided a dollar into 4 quarters. So when I'm looking for the half of a dollar, which is 2 quarters, and if I look for these 2 quarters from here to here or from here to here. When we are talking about spread or quartiles or 5-number summary, it is nothing different than what we have just done. So this median on the left of the median is your first quartile. And this is your third quartile. And we do not use quartile 2 because median is your quartile 2. So this is called your minimum because you started from here. This is called your maximum because that's the maximum we have. The center is my median and left is my quartile 1 and quartile 3. So let me write it in a better way. So we start, when we write about 5-number summary, my first one is minimum and maximum that is provided to me in my data set. What I did, first I find the median. So this is my center, 50%, half the observation on the left, half on the right. And then I calculated another median, which is my quartile 1. So 25% here, 25% here. And then I calculated another median on the right, 25 here, 25 here. And this whole thing is called your 5-number summary because we get 5 numbers. One is minimum, second is Q1, third is median, fourth is your quartile 3, and 5 is your maximum. And this is called our 5-number summary, which help us to calculate the spread of the distribution using median as the center. So let me just read that. So this is calculated using the minimum and maximum value in your data set. So you look at the minimum and maximum. So the range is the measure of the difference between the largest, or you can say the maximum and the minimum value. First thing, calculate your range. That will give you your minimum and maximum difference. Once you get the range, and again, range is not a resistant measure. It depends if you have outlier in your data set or not. Quartiles. There are 3 quartiles, Q1, Q2, Q3, that divides the entire data set into 4 equal parts or quarters. That's what we just discussed. When you are looking for the quartile or the median, make sure you need to organize or order your data set. Q1 is the median of the number smaller than your actual median, and Q2 is your center or the median, and Q3 is the median on the larger than your actual median. Q1 smaller than the median, Q3 larger than the median, and you can think of that as, so if I'm talking about this, so I have 50% area to the right of the median and 50% to the left of the median. And if I'm using Q3 and Q1, so I know that 25 So if I'm looking for the area above Q1, or if I'm looking how much of the observation above your first quartile, we have 25, 25, 25. So we have 75% of the observation above Q1. How many below Q1? 25. Same thing, how many above Q3? You can just see there is only 25%. How many below? 75%. So it's just like you are dividing distribution into 4 equal parts. So first find the median, and then to the left, right. And again, the distribution is skewed. So there are 25% of the observation here. There are 25 here, 25, 25. But depending upon which direction or where your outlier is, you have 25 observations, let's say all here, but 1 observation here. And that is making your distribution skewed to the right or left. So Q3 is the median of the numbers larger than M. 75% of the observations are smaller than Q3. It is hence referred as 75th percentile, and Q1 is referred as 25th percentile. Since median is in the middle, it is called as 50th percentile. 5-number summary, we already discussed. This is how we calculate 5 numbers, minimum, maximum, always given to us. Once you range, you know what your minimum and maximum, find your range. Once you find the range, find your median, and then find 2 more medians, one on the left, one on the right, and you get your 5-number summary. This 5 number summary is important to understand because this 5 number will help us to find the suspected outliers. It will help us to detect if there are outliers in your data set. So you need to know how to calculate your 5 number summary. Once you have 5 number summary, you can make the box plot. So we talk about histogram, we talk about stem plot, and now how to make a box plot. When you are going to make a box plot, you need these 5 numbers. With the help of these 5 numbers, you can make a 5 number box plot. How to make a box plot? First of all, look for which direction, how do you want to make. You can make a box plot both horizontally or vertically. When you want to make a box plot, first thing is you look for your Q1 and Q3. Once you know your Q1 and Q3, make a box using Q1 and Q3 depending upon what your data set is. Once you have this Q1 and Q3, now look for your minimum and go to minimum using a whisker and stop there. Same thing, now look for the maximum and go there and stop. And then use your median, where your median is depending upon what is on your y-axis, and that will give you a box plot. So it has 5 numbers. This is your minimum, that's your maximum, this is your median, this is your Q1, and this is your Q3. When you use a software, it will give you your outliers also. And if there are outliers in the data set, like you can see that the distribution, if I look at this from here to here, the distribution is going more towards the right direction. So there are outliers in your right direction. So when you plot this in any software, it will give you how many outliers or how many possible outliers in your data set, and these small dots will represent your outliers 1, 2, and then you can find it manually also using the formula that we are going to use in a little bit. Any questions so far? Anyone has any questions for me? All right, if not, we still have 10 more minutes. No, 18 more minutes, so we can cover one more topic. You can make this box plot, as I said, horizontally and vertically. So if you want, you can make the box like this. Your minimum here and maximum here, and you here represent your data set. And this is your minimum. This is your Q1, median, Q3, and maximum. In your homework assignment or quiz or in your task, you will not be asked to make a box plot, but you need to know how to read a box plot. So what is this means? What is this means? What is the range of the data set? Where is my median? Where is my Q3? Where is my Q1? What is 25th percentile? What range your 25th percentile is, what's the range between Q1 and Q3. So you need to know how to read a box plot, but you will not be asked to make a box plot in any of your assignments. So this is how you make a box plot. Once you know how to find a 5 number summary, you are good to find, or you are good to look at if there are outliers in my data set, and if yes, how many, which is my outlier, or what are the numbers, what places I have outliers. Then if I remove my outlier, what is my range that gives me a good distribution that is not having outliers. So spotting suspected outliers and modified box plot. So once you spot the suspected outlier, then you can make a box plot, and then you can use how many suspected outliers you can have in your data set using these symbols. So first of all, when you are looking for how to find the outlier in your data set, first find the range of the distribution. When you find the range of the distribution is maximum minus minimum. We just learned, right? So that's how we find the range of the distribution. Once you find the range of the distribution, and again, if your data set is not organized, your range will be wrong. And if you get the wrong value for the range, whatever you are doing next will be not correct either, because you work with the range to find the suspected outlier. And if your range is not correct, no matter what you do, you will not get the correct answer. So first look for the lower and the higher number in your data set, and then subtract them to find the range of the distribution. Once you find the range, you can find your 5-number summary. You can calculate your 5-number summary. Once you find your 5-number summary, that means minimum and maximum you already have in your data set. Then you calculated your median. You calculated your Q1 and Q3. So you have your 5-number summary ready. Now calculate interquartile range. We know what range is, minimum minus maximum. When we are saying interquartile range, what does that mean? We are looking at the difference between two quartiles. So then we will calculate Q3 minus Q1. So we will look at the interquartile range, or the range between two quartiles. What are my two quartiles? Q1 and Q3. So I look for the interquartile range, which is Q3 minus Q1. So once you have that interquartile range, the range of the 50% of the data is in the center, because we are talking about this part, right? So 25%, 25%, 50%. 1.5 IQR rule. Now you are using this rule to detect the suspected outlier. Once you find the interquartile range, multiply this with 1.5. So you are looking at this. How do I find the interquartile range? I look at two quartiles. But to find these two quartiles, I need to find my 5-number summary. And to find that 5-number summary, I need to look for my range. So look for the range, look for interquartile range, and then multiply the difference of that interquartile range, Q3 minus Q1, with 1.5. Once you multiply this, now look for this formula. Let me write here. Q3 plus 1.5 IQR. So what you get here, you add this to third quartile and subtract this. Let me see. If an observation is greater than this, or if an observation is, make it Q1 minus 1.5. So please do these changes in your chapter notes that are uploaded on Canvas. So if an observation is greater than Q3 plus this and less than this, so that means your 5-number summary, if anything is less than the range for this Q1 and higher than this, that is your suspected outlier in your data set. And there are example, I think there are examples solved in your slides. If not, definitely in the book. And if you want, I can go over one of the examples in the next class. So when we are looking for the outliers in your data set, and there are questions in your homework assignment and quiz how to find the suspected outlier. So first look for Q3 minus Q1, then multiply it with 1.5, you get some value, and that is your interquartile range. Once you get that interquartile range times 1.5, once you get this value, go to your third quartile in your data set and add this part. And let's say I get an observation 300, just random number. If I get this observation and Q1 minus this part, and let's say I get 20. So now this is your range of the data set. Anything outside this range in your data set is your suspected outlier. So go back to your data set, look at the range. If anything outside this, lower than 20 or higher than 300, that is your suspected outlier. So let me see in the lecture slides if we have an example. Here. So if you take a look at lecture slide page number 32, an example is solved how to calculate a suspected outlier. So Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. Anything outside this range in your actual data set is a suspected outlier. So take a look at this one. And if you have any questions, then let me know. So this is when we are looking at the spread of the distribution. We found 5-number summary. We use that 5-number summary to make box plot and also how to find the suspected outliers in your data set. Now, if we take mean as the center, what should be my spread? My spread should be standard deviation. So if I'm taking mean as the center, my spread is standard deviation. I use median as the center. My spread was quartiles, right? And spread is how far each observation away from the center. So when we are talking about standard deviation summarize how much all the observation vary from the measure of the center, which is the mean. So if this is the mean of the distribution, if I'm looking for this, how far is this from here? How far is this from here? So I am looking for standard deviation. How to calculate standard deviation using your mean. So there is a big formula how to calculate standard deviation manually, and there is also you can use calculator, and you will find a document uploaded in the chapter 1 how to find standard deviation using calculator. So I will prefer you to understand the reason where is the standard deviation coming from. But again, I will suggest you to know how to use calculator to calculate your standard deviation, because if you have question in your test or final exam, definitely if you have a bigger data set, it will take some time to calculate your standard deviation manually. So when we are looking for the standard deviation, this is the formula we use. And let me tell you what this formula actually tells us. So when we calculate mean, this is the how we calculate the mean. When we are looking for the standard deviation is basically I'm looking for how far each observation away from me. So first thing I need to know what my mean is. So first I calculate this mean, then I subtract each observation from the mean, and then doing the square, and then dividing with, and then this is let's say x1, and then x2, keep on doing depending upon how many x's I have, and then divide with n minus 1. So this gives me the variance of the distribution. But we are looking for standard deviation, then standard deviation is the square root of the variance. So when we calculate standard deviation, we are using the formula for the variance and doing the square root for that. So this is the standard deviation formula. And if I'm looking for the variance is summation of xi minus x bar squared n minus 1. Let's say your standard deviation is given to you as 4, and the question said, let's say standard deviation is 4, and the question is asking what is the variance of your data set. You do the square of that, then you get the variance. And if you're doing the square root, then you will get the standard deviation. So let me go to the slides. Questions so far? So the most common measure for spreads look at how far each observation is from the mean, and this measure is called your standard deviation. The standard deviation Sx measures the average distance of the observation from their mean. It is calculated by finding an average of the square distances and taking the square root. So this is what exactly we just discussed. You first calculate the mean, then subtract mean from each observation, then do the square and keep on adding for all. And then you get your standard deviation. Looking at the formula, I don't think that it is very convincing that I understand what standard deviation is. So let's do an example, and that example will help us to understand how to calculate standard deviation manually. But again, you don't have to do it manually. but let me just quickly go over. Consider the following data for the number of pets owned by a group of children. Calculate the mean, calculate each deviation or observation. Deviation is observation minus mean. So this is my data set and I plotted on that. So 1 and then at 3, 1, number of pets, number 1 has 1, number 3 has 1, number 4 has 3 pets, 5 has 1, and similarly, whatever my data set is given to me, I plotted. Now I calculated my mean, which is 5. So this is my mean for this particular data set. Now I'm looking for how far or how many deviations from the mean for this one. If I'm looking for how many deviation, my mean is 5 and this is 8. So 8 minus 5 is 3. So it's 3 deviations away from the mean. This is 4 deviations away from the mean. This is 1 deviation away from the mean. But if I'm going in this direction, I see negative sign. What does that negative sign tell me? So let's say I'm going to start a walk. Let's say I want to do a 5K and I start from Patty Building and I go to the right of the Patty Building to do the 5K and I say, oh, I completed my 5K today. But if I started from the left side instead of right side, and I completed my 5K and I say that, oh, I did negative 5K today. Can this be a possibility? Can we do negative? Can we cover negative distance?
No.
No. So this negative sign tell me that this is the deviation on the left of the mean. So it is lower than the mean. That's why I have negative 4. So it does not mean that I covered 4 deviation, negative 4 deviation. So I did cover distance. How much? 4. So it is away from that. So when you see this, so here it's negative 1, it's negative 2, negative 3, negative 4. So this negative is just telling me that it's on the left side of the mean. Positive is telling us it is on the right side of the mean. So remember that a standard deviation can never be negative because it tells us how far each observation away from the mean. So it will always be positive. So it's always be positive. So it's always greater than 0. Can it equal to 0 also? Yes, a standard deviation can equal to 0 also. Let's say I took your test 1 and all of you got 95. So if you got your not every single student got 95 out of 100, what will be my mean? What will be my standard deviation? How far each observation away from the mean? So here in this case, my mean is 95. So if I'm looking at the standard deviation, it will be 0. So if you have all the observations same, your standard deviation is 0. Otherwise, it's always greater than 0. It can never be negative. So you cannot measure the distance in negative. How to calculate standard deviation? First thing, you write your xi's, so your x observation. You calculated your mean, which is 5. Subtract 5 from each observation, and then you get this. So when you do the sum of this, since they are not big numbers, can one of you tell me how much this sum should be? Any one of you? We have both negative and positive numbers, right? Because we are looking at the deviation on the left and right. Anyone? 0. Do you guys think 0 should be the right answer? Is there a typo or something? No. When you look at xi minus mean, so basically you are subtracting each observations from the mean to the left and right, and it is your center. So when you look at the sum, because when you do, you will get both negative and positive numbers. So when you get both negative and positive number, your sum should be 0. And if your sum is not 0, that means you did somewhere some calculation incorrect. So fix that. Now since the sum is 0, we are not done here. So what we need to do, we need to do the square so that all our negatives will convert into positive. So you do the square, negative 4 squared 16. So when you do the square, now every single thing is positive. Now find that sum, and that sum will be 52. When you calculated this sum, then you go back to your formula, which is this one. So this part is the sum that we just calculated here, this one. So this is nothing, it is the sum of xi minus x bar squared. That's what we have here, which is 52. Now if I'm calculating the standard deviation, my formula is xi minus x bar squared divided with n minus 1 square root. So this is 52. How many observations I have? 9. If you look here, I have 9 observations. 9 minus 1 divided with this. And when you solve it, that is your standard deviation. And we discuss about the property of standard deviation. It can never be negative, 0 or greater than 0. It is not resistant to outliers. And why it is not resistant to outliers? Because we use mean as the center. And mean is not resistant to outlier. If your mean changes, it will change your standard deviation too. And it has the same unit of measurement as the original observations. And I just noticed that it's already 11:50, so I will stop here. So we are kind of done with 1.3, and I will talk about this. And you do not have any questions on this topic in your homework assignment, and you will not be tested on linear transformation, but we will quickly talk about this in the next class, and then we'll start 1.4. If you guys have any questions, me and Miss Minion will be here from 12 to 1, so feel free to stop at our office hours. Everybody have a wonderful day, and I'll see you guys on Wednesday.
Thank you.
Thank you.
Yeah.